I'll so let's first review what we learned last time. So last time we have learned what an atom is, what a matter is, the structure of an atom, the atomic number and period table, and electron shells, ion and ionic compounds, chemical equations, and acid and base. So let's start with some simple review questions. So anything that has mass and occupies space is a matter. So matter has mass and occupies space. It has both the properties. And its smallest unit of matter that retains the properties of an element is an atom. So remember, the atom is the smallest unit of matter. And matter is anything that takes up space and has mass. And an atom consists of three types of particles. The three particles are protons, neutrons, and electrons. You can see on the right the structure of an atom. You can see protons and neutrons in the center and electrons orbiting around. That is the basic structure of an atom, and atoms cannot be divided because remember how it's the smallest unit of matter, it's the smallest possible way that retains the properties of an element. Two main particles in the nucleus of an atom are the nucleus is the center of an atom. And those we have talked about are protons and neutrons. Look back at the diagrams too, that we have protons and neutrons in the nucleus. And the number of nucleons are the number of protons plus the number of neutrons. So nucleons are protons and neutrons combined. So it's the number of particles in the nucleus. They're called nucleons. And the periodic table is the arrangement of elements according to increasing atomic number. So we will see how periodic table lists the elements. It's a convenient way to look at every element by the increasing atomic number. And what does that atomic number tell us? Well, the atomic number equals the number of protons in that atom. And that also equals the number of electrons because protons have a positive charge and electrons have negative charge. So they must have an equal number of protons and electrons. And they need to make a neutral charge overall. So the same number of positive charge and the same number of negative charge makes the atom neutral. So that is the basic components of atom. Since the new laptops have just joined, I will let some of you look at the slide for a moment, just in case some of you guys didn't see it. But here was where I talked about matter, the atom, and parts of the atom. And here is where I talked about the nucleus, center, which contains protons and neutrons, nucleons, atomic number, and um, the charges. So this is the review slide for that. And the next slide has the periodic table of the elements. So this is where I talked about how there are increasing atomic numbers as we go left to right and then down. So let's look at carbon more specifically. Carbon is over here. If we magnify that, then we have this. So on the top, you see the number 6. So this is the sixth element on the periodic table, and it tells us the atomic number. And that atomic number, remember how it tells us the number of protons, and that also equals the number of electrons. So carbon has 6 protons and 6 electrons. In the center of this part of the periodic table has a symbol. The carbon's chemical symbol is C, standing for carbon. And on the bottom here has the atomic mass. Atomic mass is 12.01. And this atomic mass is almost equal to the mass of the nucleons, which are the masses of number of protons and number of neutrons combined. So we add 6, and then if we have another 6 neutrons, then it would make up 12 in atomic mass units. But there is also this 0.01. And because electrons are extremely small, they are either negligible or really, really small. So that is why they added the 0.01 as well. That is to the account of electrons. But most of the times, the masses of electrons are negligible. You don't have to count them because they're so small. On the left here is the diagram of this structure of a carbon. You can see protons, there's 6 protons, 6 neutrons, and 6 electrons orbiting around. Now, the number of electron shells an element has is equal to the period number. And period number increases as you go down the rows of the periodic table. And first electron shell can hold up to 2 electrons. And the second shell can hold up to 8 electrons, and the third shell can also hold up to 8 electrons. If we quickly go back to the periodic table, you can see the period number increasing as you go down by the rows. So hydrogen and helium, period 1. This whole row over here is period 2, period 3, and so on as you go down by the row. And we can see that the first electron has 2 electrons, the second shell has 8 electrons, and third shell can hold up to 8 as well. And the number of electrons in the outermost shells, so we can calculate the electrons in the outermost shell by simply using the number of electrons each shell can hold. So for calcium, it has an atomic number of 20. This tells us that there are 20 protons and 20 electrons. So what we can do for electrons is that we can set up the 288 and then so on structure. So what we can simply do is try to fill up the shells. We can completely fill up the first shell by putting in 2 electrons since we have 20. We still have 18 electrons left because 20 minus 2 is 18. we can also fill up the second shell, which has 8 electrons. Now we have 10 electrons left, and we can completely fill up the third shell as well. And after that, we have used 18 electrons. We still have 2 more. We put the 2 at the end, and that does not completely fill up the fourth electron shell. So we can see that calcium has 2 electrons in the outermost shell. The outermost shell is also called the valence shell. Let's look at chlorine. Another example. We have atomic number of 17. And that tells us that there are 17 electrons. And we can structure that in similar ways by using the 288 structure. We can see 17 completely fills up the first shell by 2, fills up the second shell using 8, and since we used up 10 in total out of 17, we have 7 electrons left. That does not completely fill up the third shell, and we can see that the last shell, the outermost shell, has 7 electrons. Another way to look at it is if you have a periodic table, then it is pretty easy to look for the period number. So you can calculate the number of valence electrons simply by looking at the periodic table's columns. So the first column over here can see on their valence electrons, the outermost electrons, they all have 1. We can go down the columns, so this whole column over here has 2 valence electrons. And we actually skip over to here, and this column has 3, and 4, 5, 6, 7, and 8. That is another convenient way you can calculate the valence electrons from the periodic table. And now we can actually connect this to ions really easily. So you see from the outermost shells, calcium has 2 extra electrons. You can see 288 is complete. It is very stable at that part. But calcium has 2 more electrons. But calcium does not want that. It wants to go to the 2-8 structure. So it tends to get rid of the extra 2 electrons. And that makes the ion Ca2+. Electrons are negatively charged. So if you remove 2 electrons, it makes calcium positively charged by 2. For chlorine, we see that the last shell has 7 valence electrons. Chlorine is closer to 8 to the next shell rather than 8 to the previous shell. What this means is that it's easier for chlorine to gain an electron rather than losing 7, because all elements wants to reach the 288 structure. So chlorine wants to gain an electron to make it 288. Because 7, you only need 1 more electron to become stable. So since electrons are negatively charged, we have chlorine minus. It's 1 minus, since it needs 1 electron. So we can simplify. we can call them names. So when an atom loses an electron, the ion formed is called a cation, which is also the metals, as we call them. When an atom gains an electron and forms an ion that is negative, it is called the anion, which are the nonmetals. So examples of cations are Na plus, Ca2 plus, sodium ion, calcium ion, K plus potassium ions, Mg2 plus magnesium ions, and Al3 plus aluminum ions. And we can see the anions as well. It has the negative charge since it gains an electron. Examples of chlorine ions, Cl minus, oxygen ions, O2 minus, dioxide ions, OH minus, sulfate ion, SO42 minus, sulfur ion, S2 minus, and fluoride ion, F minus. All of those gains an electron, so it has a negative charge and are called anions. And going back to the periodic table, this is really easy if you look at it because you can easily tell that every atom wants to be the group 8 over here on the far right. These are the most stable atoms in the periodic table because they have a complete 8 valence electrons. So these are the most stable, the one on the very right. All of these elements are very, very stable. We have looked at chlorine, and chlorine is only one electron away from becoming similar to argon, which is stable. If you gain an electron, which has a negative charge, we gain an electron from the chlorine, then this gets a 2 from 2 to 7. We see here 287, sorry, to 288 because 7 plus 1. We gain an electron. So it has this stable form. And you can easily see from the periodic table it's 1 away. If it gains an electron, then it becomes an argon. For calcium over here, you can see that it is 2 away. So 1. If it loses 1, it becomes potassium. If it loses another 1, this goes back to argon. So you can see calcium needs to lose 2 electrons to become stable. And you can obviously see this from 2-8-8-2 structure. If you just lose the 2 electrons, it becomes a 2-8-8. And if it loses an electron, then it becomes a positive charge overall. I hope everything is clear so far, but we have to move on because we don't have much time. So let's solve a theory question using these ionic compounds. So let's consider the given elements. So X and Y. So you can see here that X has the atomic number of 3. So if it's in this notation, for example, the one on the top is the atomic number, and one on the bottom is the atomic mass. So don't be surprised if they give you this sort of format. The top is the atomic number, bottom is the atomic mass. And so the number of electrons in the outermost shell for lithium is 1. So we have 2, 1. And we can see from the periodic table that lithium is over here. So it has the atomic number of 3. We can predict that this X is lithium. For Y, the atomic number of Y is 9. That makes it fluorine. Again, you can look back at the periodic table and see that actually the atomic number of 9 is fluorine. And what this tells us is it has the 2-7 structure because it fills up the first shell and 7 on the second shell, and it requires 1 electron to become a 2-8 stable structure. So Y has a charge of 1 minus. Similarly, X has a charge of 1 plus because it's a 2-1. It loses the 1, then it becomes stable. 2 electrons in the valence shell. So the first question is write the electron configuration of Y, which we've done is 2-7. For the second question, need the possible ion that could be formed by X to make it more stable. We already said that X plus is stable because if it removes 1 electron, X1 plus positive charge, and it becomes 2, which is the stable form of the valence electrons. So 2, 8, 8, all of those following atoms are stable. Now the next theory question, these are again, just practicing together. We don't need to solve it right now, but I'm just going to describe it so that it makes sense to all of you. So we have all 3 of these atoms, Na sodium, N nitrogen, C carbon, Li lithium. So consider the following elements and state which element is or are metals. So metals, like we have talked about, are cations, and cations form positive ions. So we can simply see which ones form positive ions. We can either look at the periodic table simply, or we can also calculate it like we did before using the 2-8-8 structure. So if you do all that, since I don't have time to show that, but if we form out the 2-8-8 structure, we can see that sodium, Na, and lithium, Li, requires an electron, requires to lose an electron to become stable, and those ions, therefore, are positively charged because it loses electrons. So those are Na and Li, sodium and lithium. They are the metals. Moving quickly on to the next theory question. So an atom has 13 protons and 14 neutrons. So it tells us to draw and label the structure of the atom. I have one diagram on the right, which is an aluminum because aluminum has an atomic number of 13. But you probably don't need to write aluminum because you simply need to draw the atom. So what you can do is just draw 13 circles and maybe put a positive sign in it to mark it the protons. You also need to draw 14 on the center as well, marking the neutrons. You don't need to put any charges because neutron is neutral, does not have any charges. And what you can do next is draw the electron shells. with the number of electrons. Remember how number of proton equals the number of electrons in its element form, not its ion form. So, because aluminum has 13 electrons, we fill up the first shell by 2, since it has the 2-8-8 structure again. It fills up the first shell with 2 electrons. We have 2 over here. And first one is filled. Let's move on to the second electron shell. We fill up 8 here as well. 2, 2, 2, 2. Fills up 8. And we have used 10 electrons so far. We have 3 more electrons to go. So on the third shell, we fill up 3. 1, 2, and 3. And the second question actually tells us to state its valency. Valency just means the valence electrons, the outermost electrons, which we can see from the drawing that there are 3 valence electrons. And what ion will aluminum form? Well, we can easily see from the diagrams that aluminum has 3 extra electrons. So aluminum wants to lose these electrons, these outer 3. If it gives away the 3 electrons, then it forms aluminum 3+, because we remove the negative charges of the aluminum. Now it has 3 more positive charges. It becomes aluminum 3+, Al3+, in its ion form. Okay. Hope that is making sense for everyone so far. But now we're reviewing the some of the ionic compounds. These are also really, really important. So what you can do with ionic compounds is match the number of negative signs with the positive signs by having one or more ions if it's necessary. So let's look at calcium hydroxide, for example. Calcium has 2+ ion, calcium 2+. Hydroxide has OH-. So can we do CaOH? No, because that does not make it a neutral charge, because 2 minus 1 is still positive 1. That means we need 2 hydroxide ions. We need 2 OH minuses. And since we have 2 minus, calcium has 2+, it cancels out and becomes 0 charge. So the ionic compound of calcium and hydroxide combined is CaOH2, OH2 requiring 2 hydroxides. Let's look at sodium chloride next. Sodium has a charge of positive 1 plus 1 plus. Chloride has a charge of Cl minus. Since they both have 1 minus and 1 plus, they cancel simply. So sodium and chlorine ion combined is NaCl. It's also the table salt that we use for cooking. And magnesium hydroxide, we can see magnesium ion is Mg2+. Hydroxide ion is OH-. We need 2 hydroxide ions. So this becomes MgOH2. That is how you form the ionic compounds. So you will get pretty used to this if you practice enough. You can just also memorize that Na is always 1+, Cl is always 1 minus, those common ions. Calcium is always 2 plus, and oxygen is always 2 minus. Those things will come naturally, and if you practice enough, you'll start to understand it and maybe memorize it better. And the common name of magnesium hydroxide we have seen above is the milk of magnesia. It's also important to remember because it helps neutralize stomach acid and relieve stomach pain. And the ion that causes hardness in water is calcium ion, Ca2 plus, and magnesium ion, Mg2 plus. These are just things to memorize because it might come up on the test. These are some common types of questions on the test. And sodium carbonate, Na2CO3. And we can also form this ionic compound by using the charges, which we actually have Na plus and CO3 2 minus. So we need 2 sodium ions and it forms Na2CO3. That is how the ionic compound is formed. But that sodium carbonate can be used to remove permanent hardness in water. So you can see on the right, it is sort of like removing the hard water, since hard water that contains, for example, calcium goes through this container filled with sodium carbonate, and the soft water goes out. So get one more theory question regarding the similar questions. So the first question asks us, what is binary compound? Well, a binary compound is a chemical compound composed of 2 different elements. Any compound that has 2 different elements is called binary because binary means 2. Compound means multiple, so binary compound, 2 different elements. Second question, write the chemical formula of the compound formed between oxygen and lithium and magnesium and chlorine. So we have practiced this already. We see that lithium has 1 plus because it has 3 electrons and 2, 1, it needs to lose 1 electron to form Li plus. Similarly, with oxygen, we have 8 electrons, so 2, 6, it needs to gain actually 2 electrons to form a 2, 8. Since lithium has 1 plus, oxygen has 2 minus, we need 2 lithium ions. So the chemical formula, the ionic compound that forms, is Li2O. Magnesium and chlorine, we can do similar things. We see here, magnesium has 2 plus, chlorine has 1 minus, so we need 2 chlorine ions, chloride ions, and it becomes MgCl2. Binary ionic compounds we have done so far is formed between metals and nonmetals. You see this pattern, metals are positive ions, nonmetals, negative ions. So ionic compounds are basically positive meets the negative, and it becomes neutral. So typically, the metal, the cation, the positive ions are written first. If you're naming it, then it is followed by the nonmetal. And the nonmetal's name ends with an I. So if we look at magnesium and chlorine combining together, We actually have magnesium ion and chloride ion. Since it becomes an ion, it needs an ide. And if you combine them, it becomes magnesium chloride. And we have two examples here. Um, Also, Li2O, you can also name it lithium oxide because lithium and oxygen, you don't call it lithium oxygen, you call it lithium oxide. You need the IDE ending for the nominal. Oh, and let me just ask you another question. What about for NaOH? How would you name this ionic compound? Does anyone want to try? Or so we have Na plus combining with OH minus. How would you name this compound? Well, if you want to name it, then it becomes sodium, and this is hydroxide. So simply, you can name it sodium hydroxide. And this is important to memorize. It's important to memorize that OH minus is an hydroxide ion. It's maybe something you have to memorize and keep it in your mind because it comes in the test often. And you need to know that Na is sodium, although Na does not look like sodium, but it is actually named sodium. And similar for Mg, you need to know it's magnesium. Cl, you need to know it is chlorine. And Li for lithium, O for oxygen, all those naming things. Let's look at another theory question. Um, so describe briefly the formation of ammonia. Ammonia is NH3. It's also important to know. And from the molecule of hydrogen and nitrogen atoms. So hydrogen has one valence electron and one more electron to complete its shell. Since nitrogen has 5 valence electrons, it needs 3 more to complete the outermost shell. So hydrogen has just one as in its first electron shell. It needs to add one more to become a 2. For nitrogen, it has 2 and 5. It needs 3 more electrons to complete its outer shell. And over here, you can see that 3 hydrogen atoms on the right combines with 1 nitrogen atom to form 3 bondings. So hydrogen and nitrogen, they both need electrons. So what they do is share. This is actually called a covalent bond, but that is just another name. And each hydrogen atom shares 1 electron with nitrogen atoms to form NH3. You can see that they are sharing electrons, so hydrogen adds 3 electrons to this orbiting area, And nitrogen also provides the extra electrons for the hydrogen, so they exist pretty well. You can see that hydrogens and nitrogen are helping each other. Nitrogen providing extra electrons for the hydrogen, and hydrogens also providing extra electrons for the nitrogen. And all of them become stable. Hydrogen has 2, which is stable. Nitrogen has 8, and the outermost shell, which is also stable. This is how you would describe how NH3 is formed. So this is not a combination of an ion. It's not an ionic compound because this is from hydrogen, which is also 1 plus, and nitrogen, which is also 3 plus. Since both are plus, it's not really an ionic compound. It's what's called a covalent compound, which means sharing electrons. You can see there are different types of bonding and compound. So this is just another example. Okay, I saw that some of you guys were pretty having a difficult time with balancing chemical equations. So let's look at a few of them. So balancing chemical equations, so for H2 plus Cl2 equals HCl. What can we do to balance the equation? Well, we have on the left side 2 hydrogen atoms and 2 chlorine atoms. So you have 2 hydrogen, 2 chlorine on the left, but we only have 1 hydrogen and 1 chlorine on the right. So what we need to do is put 2, and this balances it because 2 hydrogen and 2 chlorine atoms. And what you can do to these coefficients, you can just put 1 because it's already stable if you put 2 on the right. That balances it. Let's look at the second example. Just H2 plus O2 combines to form water, H2O. What we can do here is, since we have 2 oxygens on the left and only 1 oxygen on the right, we can multiply the water ox by 2. This becomes 4 hydrogen atoms on the right and 2 oxygen atoms on the right. And oxygen on the right equals to the oxygen on the left. So oxygen is fine, but hydrogen is not. Because we have 4 hydrogen on the right, but on the left, we still have 2 hydrogens. What we can do here is multiply this hydrogen, H2 on the left, by 2. This makes it 4 hydrogen atoms, and it balances it. We can double check it by counting each one. So 2 times 2, we have 4 hydrogen on the left. We can just mark it. What I like to do is actually separate these two and label it. So H, we have 4. On the right, H, we have 2 times 2. We also have 4. Let's look at oxygen. Oxygen on the left, we have 2. On the right, we also have 1 times 2. So we have 2 oxygen. The number of hydrogen on the left equals the hydrogen on the right. The number of oxygen on the left equals the number of oxygen on the right. So it balances the equation. That is how you would go through each one carefully. and balance the equation. Now that I hope you understood it, I'm going to move through it a little quicker pace. So Na plus Cl2 is NaCl. Two chloride atoms on the left, we need two chlorine atoms on the right, so we multiply this by 2, NaCl, which is also salt. And we only have one sodium atom on the left, so we multiply this by 2. And you can check that everything is balanced. For the fourth example, we have magnesium, Mg plus O2 oxygen goes to MgO. Again, we need to multiply MgO by 2 because we need 2 oxygens since it only has 1 oxygen. This makes it, however, 2 magnesium atoms on the right, but we only have 1 magnesium ion, so we multiply this by 2. And you can check that everything is balanced. And this is how you would balance any chemical equation, really. You'll need to know this method. I hope that made sense for everyone. But I will be moving on. If you have any questions, you can ask them now or later, at the end of this lecture. But let's look at another theory question regarding a similar concept of balancing equations. So this is a pretty difficult one, but let's carefully go through this one. So a student who went to bed immediately after eating complained of stomach upset the next morning. A doctor prescribed a liver salt whose major composition is NaHCO3 as the medication. Using a balanced chemical equation, explain how the liver salt would relieve the student from this discomfort. Liver salt is antacid and it neutralizes the excess acidity. So acidity in our stomach acid, remember it's from HCl. Stomach acid is HCl. It's maybe something you need to memorize as well. And HCl combines with this liver salt, NaHCO3. And what this forms is NaCl and water and carbon dioxide. It forms these 3 compounds. And NaHCO3, this liver salt, acts as a base, and that can neutralize stomach acid. So, always remember that combining an acid and a base forms salt and water. So you can see acid HCl and base NaHCO3, acid plus base is salt plus water. So NaCl is a salt. It's a typical table salt as well. And it forms water. But this case is special because it has the CO3 attached to it. That basically forms extra carbon dioxide, CO2. Now this was a little difficult, but you can also check that the equation is balanced since our focus is balancing the equation. Let's quickly check. On the left, for hydrogens, we have 1 over here, 1 over here. 2 hydrogen atoms on the left. We also see 2 hydrogen atoms over here on the right. Hydrogen is good. Let's look at chlorine. 1 chlorine on the left, 1 chlorine on the right. That is also good. Let's look at sodium. One sodium on the left, one sodium on the right. This is balanced. For carbon, one carbon on the left, one carbon on the right. Carbon is also good. Finally, let's look at oxygen. Three oxygen on the left, one over here, T over here. So 1 plus 2 is 3. So oxygen is also balanced. So everything is balanced in this equation. The difficult part is forming the equation because that forming this equation is actually pretty difficult. And not many high school students can probably solve this problem because you need to know the HCl is the stomach acid and NaHCO3 is a base. So remember, now you know that acid plus a base is salt and water, sometimes extra CO2 if we have CO3 mixed in it. Now, um, moving on to the next theory question. Explain briefly what is observed when pieces of each of the following metals are dropped into two separate test tubes, each containing dilute hydrochloric acid. It's basically asking you um, which ones, which metals would replace in place of hydrochloric acid. What we have to do in this question is see which atom is more reactive than hydrogen. So for magnesium, we have magnesium actually more reactive than hydrogen. We can look back at the activity series table and see that, for example, let me actually quickly show you the activity series over here. So magnesium is higher up than hydrogen. It's higher up than hydrogen, magnesium over here. So magnesium would react and react with acids. So because it's more reactive. But let's look at the second one. Silver. So if we check back again at the table over here, where is silver? Silver is all the way down here. It's highly unreactive, and you can see it's below hydrogen. It's below hydrogen over here. Silver is over here. Hydrogen is over here. And we can see that silver does not react with hydrogen. That is how you can see which ones um, would separate from when dropped into hydrochloric acid. See which one is more reactive. Finally, the last thing we covered last time was acids and bases. So, what turns blue litmus paper red are the acids. Always remember, acids turn litmus papers red. On the other hand, bases turn red litmus paper blue, since bases turn everything to turn litmus paper to blue. And red litmus paper retains its color, it keeps its color in acids. Because red acids just make it red, red from red is just acid. Blue litmus paper retains its color in bases with similar reasoning. Bases turn every litmus paper blue, so if you have blue litmus paper already, it retains its color. Neutral solutions, however, are neutral to litmus paper. There are no changes, color changes in any of the litmus paper. So examples are pure water and salt water. They're both neutral solutions. You can see also examples of acids like orange juice, HCl, hydrochloric acid, which are stomach acids as well, and vinegar. And bases examples are soap, baking soda, ammonia, and NaOH, sodium hydroxide. These are some examples. And yeah, I think we are ready to move on to second part of these new lessons. But before we do that, do you guys have any questions about the previous materials? If you have questions, then I think you have to unmute and ask. I couldn't hear you correctly. Can you repeat that, please? I can't hear anything. I will share the slides later.
How can you calculate proton and neutron?
Oh, sorry. Oh, can you repeat that, please? Can you repeat that, please?
Those of you who want to ask questions, you can.
Maybe
You
you type
disconnected
in the
our.
chat because I cannot hear you very well. You maybe type in the chat, your question. Um,
There is no display entry. You can ask your question.
How can how can you how can you calculate proton and neutron?
So how can you distinguish protons and neutrons? Are you asking?
Yes. Yes.
So protons are positively charged and neutrons are neutral. It does not have any charges. So both protons and neutrons are at the center of an atom. So the only difference are the charges because protons are positive, neutrons are neutral, and electrons are negative. You can see that protons, neutrons are at the center, and electrons are orbiting around. Does that answer your question?
Do you have any other question? Yes. How can you calculate? What is that?
Oh, you mean how can you calculate the number of protons and neutrons?
No. How can you calculate density?
Oh, you mean density. We will actually get to density later because, yeah, I will move on to the next chapter because density is covered here and measuring volume and masses. We will learn how to calculate density. But yeah, I think we're ready to move on. So I'll
Yes.
quickly get through what a mixture
Yes.
is first. So an example of a mixture is the salt solution, salt plus water. You might be asking, what is a mixture and what is a pure substance? Well, matter can be categorized into pure substances or mixtures. So mixtures can be homogeneous mixtures and heterogeneous mixtures. But essentially, mixtures are combinations of multiple compounds. The only difference between these two are that they are evenly distributed or not evenly distributed. So you can see mixture is made of two or more substances mixed together, but not chemically combined. As two or more substances, but not combined chemically. They can be separated easily by filtering or boiling. We will look at some separating mixture methods. And each part keeps its own properties. Like we've said, homogeneous mixtures has a uniform composition throughout. Examples are salt water, salt plus water, and air, which is a mixture of gases like oxygen, nitrogen, carbon dioxide. It is uniform, so basically it's evenly mixed. So even though it may not look like a mixture, it is because it is very finely mixed. But it's not chemically combined. Heterogeneous mixture, however, is not evenly mixed. So really anything can be a heterogeneous mixture, like a salad, which are combinations of vegetables, meat, and dressings. It's all a combination, so it is a heterogeneous mixture. Sand and water and oil and water are also heterogeneous mixture because those things don't evenly mix together well. Now, we also saw that matter can also be pure substances. And what this means is pure substances can be made of only one type of material and has a fixed composition. So it cannot be separated into other substances by physical methods. So while mixtures can be separated by physical methods, like like filtration or distillation, we'll look at a couple of methods, but pure substances cannot be separated by those simple methods. So there are two types of pure substances. They're elements, which is made up of only one type of atom, like gold, oxygen, copper. They are all elements. Compounds, however, are made up of two or more elements, chemically combined, like water, salt, but not salt water because water and salt cannot be chemically combined together. They can only exist as separate compounds, and that makes it a mixture, not a pure substance. Another examples of pure substance compounds are ammonia, hydrogen chloride, and way more. So which are the following substances is a compound? Remember, compounds are more than one element. So you can easily see that sucrose C12H22O11 has multiple elements, while the other, copper, is just Cu, diamond is just carbon, sulfur is just S, it's only one. So sucrose is the only substance that is a compound. So the answer is C. A substance which is made up of the same kind of atoms is called. Does anyone know the answer to this question? The same kind of atom. I think you need to unmute if you can.
Element.
Yes, that's right. It's an element. So the answer is B, you are correct. Since we can see that elements are only made up of one type of atom. Compounds are the ones that are made up of two or more elements combined. So the answer is B, an element. And next question, which of the following substances is a compound? Can anyone answer this question? It's
Magnesium.
it's actually not magnesium because magnesium is only Mg. It's a single element actually. And the only compound in this answer choices are water. So water is H2O. Oxygen, you're talking about the gas, is just O2. It's made up of single elements. It's still an element. Magnesium is just Mg. Sodium is just Na. We can see that oxygen, magnesium, and sodium are all elements made up of one type of atom. However, water is H2O. It's made up of multiple types of atoms. It has at least two, like hydrogen and oxygen. That makes it a compound. So the answer is C, water. The use of separating funnel is most appropriate in separating which of the following mixtures. So this on the right is the separating funnel apparatus. So the answer actually is D, water and vegetable oil. Because water and vegetable oil does not mix together very well. And it forms two separate layers. You can see on the right, there's oil on top and water at the bottom. They don't mix together. And this is a heterogeneous mixture. What we can do to separate these mixtures into their own pure elements, into pure substances, then we can use a separating funnel. As you can see over here, it's draining only water down and keeping oil at the top. That can be controlled by the center, which by turning on the tap. Let's look at another separating mixture method. So a solid component found on the filter paper and the liquid component that flows into the container during filtration are respectively called, right here, you can actually see on the diagram on the right that the component found on the filter paper over here, they're the residue, see in this diagram, and the component that flows into the container. And this process is the filtration process. It's called the filtrate. So we started from a mixture of liquid and solid. By moving through this filter paper, through this process of filtration, you can see the liquid, which is the filtrate, forming at the bottom, and the solid, called the residue, is forming at the top. So the answer is A. It's the liquid, it's filtrate, and the component that is still at the top is a residue. And let's look at another theory question, which asks us, yeah, that is A, that's correct. But let's look at this theory question, which asks us to describe briefly the process of this experiment. We have seen that this is a separating process. Separating funnel is what it's called. So first step is to put the mixture, liquid, into the separating funnel. Next, we allow the mixture to be separated into two layers. And third, we open the tap to drain the liquid at the bottom into the flask. We let it drain the second liquid. And then after that, we close the tap, which is over here. The middle thing is called the tap. And we close the tap after draining the bottom liquid. Now, the second question asks us to state the function for the parts labeled 2 and 4. So 2 is over here. We saw that the name of this thing is called the tap, and it regulates the flow of the liquid. We can control how much liquid goes past this tap by twisting and turning the knob. We can control how fast the liquid goes down. The number 4 is this part on the left on the outermost apparatus. And this part holds the separating funnel. It's called the stand. Third question is state 2 precautions that should be taken to obtain reliable results. So the possible examples you can say, for example, the tap should be opened gently, or the mixture should be left for some time to be completely separated. Those are just 2 examples of things you can keep in mind when doing this experiment. Let's look at this next process of separation. So mixture of alcohol and water can best be separated by, the answer is actually C, distillation. So let's quickly look at what distillation is. Distillation actually is the separation process that is used to separate a liquid from a mixture of liquids. So distillation is a great way to separate the mixture of liquids. And it bases on the boiling points of those liquids. It involves heating a liquid until it turns into vapor and then cooling it back into a liquid form. So alcohol, and we have alcohol and water in the previous example. Alcohol boils at 78.3 degrees Celsius. Water boils at 100 degrees Celsius. So if we heat up the mixture of alcohol and water, we can see that alcohol evaporates first, since it has a lower boiling point. If we increase the temperature, we reach 78.3 first before 100 degrees Celsius. Alcohol evaporates first and turns into vapor before water. And the alcohol vapor goes through the condenser and it condenses back into liquid, and it is collected on a separate flask. So the final results, we have an alcohol, which is purified, and water separated at a separate flask. We can easily see this in this diagram. So this part is largely separated into 3 parts. On the left is the heating part. In the middle is the condensation, the cooling part. On the right is the collecting part. You can see the burner bringing heat to this distilling flask. So this still has the mixture of alcohol and water. If we set up the temperature just right, only alcohol evaporates. And we can measure that with the thermometer here. If the alcohol evaporates, then it gets collected over here. And if the alcohol vapor goes down further, this is the part where alcohol gets condensed. This part is called condenser. So we have vapor going on in this funnel, but then it condenses into liquid now, because as it cools, vapor, gas turns into liquid. as it cools down. So the liquid alcohol goes down this condenser and finally is collected in this receiving flask. Here is the alcohol. It's the pure alcohol. And on the left, we have remaining pure water after the final results. Originally, this was water plus alcohol. This whole process is called distillation, separating liquid mixture. And this is based on different boiling points. Hope this made sense. And we have seen the liquid-liquid mixture can be separated by. Can anyone answer this question? If you want to answer, you can unmute and speak one at a time.
Distillation.
Yes, that is right. It's distillation. That is right. The liquid-liquid mixture can be separated by the distillation method. Remember how it's based on different boiling points of the liquids. We have some other methods listed here too, like filtration, which separates solid and liquid mixture by the separating funnel. And C, which states sublimation, but sublimation is a process that changes directly from solid to a gas. For example, dry ice sublimes at room temperature. See on the right. The process used to separate a mixture of iron fillings and sulfur is, what we can do here is by magnetic attraction. What we are using is the metallic characteristics of iron. Since iron is attracted to magnets, we can use that to separate the iron fillings and sulfur. Use magnetic attraction. I think we can stop after these two theory questions because we are running out of time. But this theory question, so the first one states to identify each of the parts labeled 1, 2, and 3. Part 1 here, we can see is the beaker. This is the beaker pouring into this funnel. Part 2 is over here. These whole thing, the solids that are collected, the filtration paper in the funnel is called the residue. This third part is actually labeled wrong. I actually have to fix it, but there's a better diagram. Here's the filtrate. This part is the filtrate. Part 3, you can see, is the filtrate. The liquid that is collected at the bottom of the filtration process is called the filtrate. Second questions ask us to name the method of separation in each of the setup. So we have two setups here, A and B. A, we have seen is filtration. B, we can see there's a magnet. So this is magnet attraction or magnetization. That is the name of this process using magnets. Third question asks us to state the class of mixtures that the experiment setup A could be used for. Remember, filtration is used for solid liquid mixture. So, because it separates the solid, collects as a residue from the filtrate, the liquid that is collected. So filtration, remember, is a way to separate the solid liquid mixture. Question 4. Give a reason for the answer stated in 3. So we have kind of already went over this, but solid particles are larger than liquid molecules and cannot pass through the filter paper. There's a filter paper over here. There's a filter paper. Only liquids can go past the filter paper. The solids are remaining over here, the top. So everything on the top that did not pass through the tiny pores of the filter paper are the solids, the residue. While the liquid or the filtrate passes through in this filtration process. Question 5. Name one possible component of the mixture in setup B. An example might be an iron filling and any other element that is not magnetically attractive. So magnetization or magnetic attraction can be used to separate magnetic components and non-magnetic components. Iron fillings and sand are examples. And this is also very useful if the mixture is finely grained. So more like powdered stuff would be better to use for magnetization. And state the function of the parts labeled 4. So over here, we saw in A that this part is the clamp stand. This is just the stand, which provides stability and safety when doing the filtration process. It holds the funnel in place. This is the last question that we will do today. And the following activities were carried out in the laboratory. Study them carefully and answer the questions. So this is what they did. 10 grams of iodinated salts was added to 150 milliliters of water in a beaker. The mixture was stirred thoroughly. Vegetable oil was added to the quantity of water in a corked flask and shaken vigorously. Few grams of grinded charcoal was added to water in a beaker and stirred vigorously and then allowed to stand. The first question asks us to state what will be observed in each of the activities in 1, 2, and 3. So we can see 1, that the iodinated salt will dissolve completely. It will form a miscible solution. It will form a sort of homogeneous mixture. For the second part, the water and the oil will separate into individual layers because remember how water and oil does not mix together well. But it's still a heterogeneous mixture. It's not uniform, but still a mixture. For the third example, charcoal does not dissolve in water. So you can see on the right, the picture here, charcoal is actually settled at the bottom. It's not mixed. Oil, you can see, is also not mixed. So this is also a heterogeneous mixture. Second question asks to suggest the aim for the experiment. The possible answer to the question might be to determine whether the homogeneous mixture or heterogeneous mixture will be formed, and to demonstrate the method of preparation of mixtures. So this experiment might be just combining the solution with a solid or a liquid with another liquid to form many types of mixtures to see if they're homogeneous or heterogeneous. That might be the aim of this experiment. So, state one difference between what is observed in 1 and 3. So 1, since iodate salt is added to water, this is a homogeneous mixture. The solute is dissolved in the solution. It's completely uniform, so it's a homogeneous mixture. In 3, however, charcoal, remember, does not dissolve in water. Salt dissolves in water, but not charcoal. So this, therefore, is the heterogeneous mixture. The last question. State a method of separation for the activity carried out in 2. So 2 over here is a mix of oil and water. But oil and water forms 2 layers. Remember how we separated the 2 layers of liquid? It's by using a separating funnel. You actually see from the separating funnel, this is a separating funnel. This is how you would separate water and oil. The top part can be the oil, this part can be the water. Remember how we turn on the tap and only the water is collected at the bottom and leaves the oil at the top. This is the only reason because water and oil forms a separate layer. That is the end for today's lesson. Do you guys have any questions for today you want me to ask before we finish? Any questions so far? If you have questions, you can unmute and speak. You can. Yeah, go ahead and ask if you have any questions. If you don't, it's also fine. But if you don't have any questions at the moment, I will be sharing the slides to all of you, so you can maybe go over some of them. Yeah, do you have a question? Yeah, it's okay if you don't have any questions. I will be sharing the slides so you can take a look at that again if anything was confusing. But I will see all of you next week and we will continue chemistry and we will finish it by next time. So we will finish chemistry and move on to maybe physics next time. So yeah, I'll see all of you next week. Bye, everyone. Bye.